So if you think of just the words domain and range, if you don't overthink it, what we know is the domain of something is basically, if we're thinking in general, like the domain of a fish is like water, right? And more like the domain of a bird is more like in the air. Is that correct? Hmm?
Okay, yeah. So let me just. Okay, can we do it?
Don't you do it?
Yeah, my little brother just visited me now. I'm sorry. Please repeat.
I was saying, if you think of the words domain and range, right? Firstly, if we think of just the word domain, in general, we can maybe say something like the domain of a fish is like water, right?
Mm-hmm.
Yeah. And then the domain of like a bird is basically the air.
So,
Huh?
I'm not getting it. Yeah, I'm not
Yeah.
getting it.
What I'm trying to say is when we speak of the domain of something, we basically are trying to say where are we likely going to find it, or where will we find that certain item. So if we're thinking of objects, like I said, the domain of a fish is like water. The domain of a bird is like in the air. So with graphs, when they speak of domain, the question will be asking you, where do you see the graph? But then the thing is, with domain, it would be asking you, where do you see it along the x-axis? Or which x values will that graph have? Or which x values will that graph potentially have? Or which x values can it possibly have? You see, that's what domain talks about.
Okay, now
Range,
I'm sophisticated.
yeah, range basically asks the opposite question. It asks which y values is the graph going to have? You see, you get it.
Yeah, yes.
Yeah. So for example, these two straight lines here, if you look at along the x-axis, right? This is the x-axis, and it is somewhat 100% clear that from left to right. Do you see that? If this is literally all you can do for yourself, you literally, if you're going to be asked for domain, right? What you literally can do for yourself is you can go to your x-axis, right? And you go to the far left. So if you're looking at the far left, you just ask yourself, will this graph potentially have this x value? And the answer is yes. You see that?
Mm-hmm.
Yeah, and if you keep stretching to the far left, will this graph have this x value? The answer will also be yes, because it will keep stretching all the way to infinity to the left, and it will always have x values going to the left. Do you see there's proof of that?
Yeah, I see it.
Yeah, and you do the same going to the right. Going to the right, will it have this x value? And the
It
answer is
will.
yes, it will. Will it have this x value? And the answer is yes, it will. And there's proof to say that going all the way to the far right, it'll always have all the x values. Hence why the
So,
domain of this graph will just say x is the element of R, because this graph will touch all x values.
so it's unnecessary to write x as the element of our open bracket negative infinity comma positive infinity close bracket.
Well, the negative infinity part, that's another way of writing what we've written out now. It's a choice. So you can either write it like this, or you can write, as you said, you can just say x is an element of negative infinity up until positive infinity. This is another way of writing it. This is like a second way of writing it, and this is more like another way of writing it. It's not to say any of them is superior to the other. It's just different options to do the same thing.
Okay.
Yeah. So when you think of now range, it's the same idea, right? When you think of range, it's the same idea. Because remember, the idea is to look along the y-axis, you see? So if you look along the y-axis, right, the idea is if you're going upwards, you see that if you're going up here, up, 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 you can pick any random y value, you see, and you ask yourself, will this graph go to this y value? Yes, it will. Will this graph go to this y value? Yes, it will. And there's proof that going all the way up to infinity, it will always touch all the y values. And then going downwards, same idea. Will it touch this y value? Yes, it will. Will it touch this y value? Yes, it will. Because it's going all the way down to infinity without anything stopping it. You see?
Oh, so y is an element of R also.
Yeah. So y is the element of R also. Meaning you can also say y is the element of negative infinity to positive infinity.
Ah, okay. The like linear one is making sense. Can we go to
Yeah.
the parabola?
Yeah. So going to the parabola, it's um it's the same idea. You just ask yourself, you just literally go to the y-axis and the x-axis. So if you look at this parabola, right? Um, we can use any of these parabolas because they all have this. Most of them have the same. Well, let's use the pink parabola. So if you're looking at the pink parabola, right, and you're asking yourself what is the domain. So as we said, what you do is literally just go to the x-axis. This is the x-axis. And then you literally just go to the far left and the far right, or you just move along the x-axis. See, this is where 0 is. So you just move along the x-axis. Will it have this x value? Yes, it will. Will it
Mhm.
have this x value? Yes, it will. What about this x value? If you trace the graph the way it's behaving, it's gonna go up, 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 and it will eventually have this x value. And there's proof to say that going all the way to the left, this graph, as it's going upwards, right, it will still touch this specific x value at some point. Do you see that?
Yeah, I see it.
It's the same towards the right.
Mm-hmm.
See, it will touch this x value, this x value, this x value, going all the way to the far right. And these, yeah, you see, as it's going upwards, you see, it's gonna be going up, 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 up. So it will have all x values going to the right. You see that there's proof of that
Yeah, I
without
see.
anything stopping it. Yeah. So that's why the
The
domain
X,
here is.
okay.
Hmm? Hmm?
What about? Oh, never mind. I answered myself.
So that's why we can say a domain x is the element of R. Range,
Mm-hmm.
we said we look at the y-axis instead. You know, you can even do it manually as we're doing it now, because even the way we're
So,
explaining, yeah.
so range, right? So in terms of the pin graph, are we going to, let's say the turning point is a -1. Are we
Mm,
gonna say y is an element of, and then open bracket, uh, what is it? No, square bracket, -1, comma, negative, no, comma, infinity, round bracket.
mm-hmm. That's exactly what we're gonna do, because you can see that the y values start from -1 and then they go all the way up to infinity.
Ah, okay.
Yeah, because the proof of that is there to say this graph has y values starting here. It doesn't have anything downwards here, but it has something upwards here. Every time you think of an x value up here, those x values, the graph is touching them.
Mm,
Yeah.
it's starting
So
to make more sense.
great. So with these upside down ones, you can even imagine it's the same thing. Let's look at even this wide one that you drew here, this orange one, the domain. There's proof to say that it will touch all the x values. You see, because as it's stretching like this, and as it is stretching like this, what we can already see is that you see there's x values here, 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 all these x values going all the way to infinity. And then it also has all these x values here, 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 going all the way to infinity. So with that being said, right, we just need to be careful. Okay, not necessarily careful per se, but we just need to know that we don't want to overthink it. So also the range, you can see anything from here. Let's say this is like 2. then we know starting from 2 going all the way down, the graph will always touch those y values. It won't touch anything upwards. So that's why when you get the range, we'll just say the y values have to be bigger than 2. I mean, smaller than 2, smaller or equal to 2.
Oh, okay, makes sense.
Yeah, yeah, yeah.
And then when it comes to a hyperbola, hello. Hello.
Yeah, bro. I'm back. Sorry.
Oh, oh,
I
oh,
muted my
okay.
mic. Yeah. But anyways, so what's the next shape now?
I want to do it for all of them here so I can make sure like I understand them. So I can also do the hyperbola. It's on the next page.
Yeah. So with things like the what you may call the hyperbola, yeah, it's the same idea, right? Because fortunately with things like the hyperbola, you want to think to yourself what you may call. Let me see what I'm saying here. Where is this one? Let's find a hyperbola. There we go. So we have a hyperbola now. We have a hyperbola.
Mm-hmm.
So with this hyperbola, we have two things, right? There's an x um, asymptote and there's a y asymptote. So if you look at the curves here, right, we have, what do we have? We have this, and we have something like this. Okay, so you can just focus on the green for now. So the nice thing about the domain and range of a hyperbola is that it's all about the asymptotes. You see, so as long as you know what what you call, as long as you know what the x and y values of the asymptotes are, then you'll be fine. So here's the point here, there's a point here. So let's say this is like a 2, this is like a -1. So the idea is, remember domain, we say look at the x-axis and just question which x values the graph is going to go to. Is that true? Hmm?
Pardon?
I'm saying for domain, we said we need to look at the x-axis, and then we need to look from left to right and ask ourselves, where does the graph go to? Which x values does the graph touch? We say that's what we need to say. What That's what we need to ask, right? So meaning we literally just we can even start here and ask ourselves, okay, these x values going to the right. You see that the graph will touch all those x values going to the right.
Mm-hmm.
Yeah. And then if we now look to the left, do you see that it will touch all these x values going to the left until at -1? Do you see that -1, it doesn't touch that x value?
Yeah,
Yeah, but then after -1, it touches everything.
that's just again. Mm-hmm.
Yeah. So that's how we know, okay, fine. This graph touches all the x values except for -1. So the domain here will just say x is an element of R. However, x cannot touch -1.
Mm. And then for y, it's y is an element of R, but y cannot be 2.
Positive 2. Yes. Y cannot be positive 2.
Ah, okay. And then the exponential?
So exponential, it's roughly the same idea. Because again, you for domain, right, we look at the x-axis and we literally just draw, when we literally ask ourselves, all these x values, this graph will eventually touch them. You see, going all the way to the far right also. our graph will eventually touch all of them. So that's why the domain here is just what you may call X is an element of R. That's the domain, right? So with that being said, right? With that being said, that's the domain. X is an element of R. The range. The thing is, with all exponential graphs, they have an asymptote. You see, all exponential graphs have an asymptote, and the asymptote is this one. You see. So if this is the asymptote, then we need to ask ourselves. You see, these are x values here, going all the way up to infinity. You see. So those x values going all the way up to infinity. I mean, y values going all the way up to infinity, and they end at whatever asymptote this is. So if this is like -3, then we would say the range is our y values need to be bigger than -3. You see, we're not saying, or the way you like it, you can say y is the element of -3 up until infinity.
Oh. Um. Oh, never mind. I answered my question again. It's fine. Um. Oh no, I get it. I get it now. I get it. I was just checking something.
Okay. So what is okay? Yeah. So that's basically domain and range in a nutshell. When you
See, it's
consider
so
all these.
easy when you explain it until I have to write it by myself.
Well, the thing is, you see how we're explaining it. The way we explain it is the way you wanna execute. You see, like us going to the x-axis and drawing the lines going down. Like that's what you actually just need to do. So you don't wanna not feel too proud to do the baby stuff or something. It's like in an exam when I don't know, you just feel the urge to use your fingers. Do it, just do it. You know, it's like there's no shame in using your fingers to like, you know, to try and really just make sure that you're doing the correct thing.
Yeah. You see the page where it says functions and graphs in purple? I think it was the number three that I picked. Yeah, the number three, the photo.
Mm. Okay, let me just stop this one since we're talking about domain and range.